Now let's talk about combinations to calculate probabilities. So in the IB, there's going to be many cases where it asks you about a probability of a number of successful combinations out of the total number of combinations. So you can expect that the equation is going to be like this. So the number of successful combinations over the total number of combinations. And we'll go through an example just like that. So a class contains 7 girls and 5 boys. 3 students are selected at random to form a committee. So you can expect out of the 7 girls and 5 boys, we're going to have many different combinations of committees of size 3. So part A says find the probability that exactly 2 of the selected students are girls. So what we have to realize here is that out of the total number of committees, we are trying to look for the number of combinations that have 2 girls exactly. So this can look kind of like if there's girl 1, girl 2, girl 3, girl 4, girl 5, and boy 1, boy 2, and boy 3. Some examples of these types of committees would kind of look like girl 1, girl 2, and boy 1, girl 1, girl 2, and boy 2, girl 1, girl 3, and boy 3, and so on and so on. So committees that exactly have 2 selected girls. So the way we would get this is by saying that it is the number of committees that have exactly 2 girls over the total number of committees possible. So let's first start out with calculating the total committees possible. This would be equivalent to 12 choose 3, because out of 12 objects, we're trying to find the total number of combinations you can get with size 3. So that is the total number of committees possible. Now, in here, we are going to say that out of the 3 slots, the first 2 we are going to dedicate to girls. And now we're going to think about how many combinations it's possible. This is going to be 5 choose 2. 5 choose 2. Because we have a size of 5 for girls, and we're taking the number of combinations that you can get with 2. So this is going to be represented as 5C2, and this is going to be equal to 3 choose 1, because we have 3 boys, and then we're trying to find all possible combinations of 1 boy. So that's going to be 3C1. And this, when you do all the algebra factorials bits in there, you are going to get 21 over 44. So that is the probability that exactly 2 of the selected students are girls. And as you might expect, when there are many different selections possible at scale, we have to use combinations because we can't just keep track of all of the committees, and we can't just write down each committee and then just count them, and that's not going to work. So the power of combinations rely on this case. Now part B asks, hence find the probability that the committee contains exactly 2 girls given that it contains at least 1 girl. So recall in part A, we achieved to get the probability of having exactly 2 girls in the committee, which is 21 over 44. And now the question asks, what is the probability of having 2 girls given that you have at least 1 girl in the committee? And using Bayes' theorem, we can reorganize it like this. Now, when we evaluate this part right here, the probability of having at least 1 girl given that you have 2 girls, this is going to be 100% of the time. Because if you're given that you have 2 girls, the probability that you have at least 1 girl is 100%. So we can actually just get rid of that by making that equal to 100% or equal to 1. And the probability of having 2 girls is given from part A, and that is going to be 21 over 44. And now it seems like the probability of having at least 1 girl is the probability that we don't know. So let's first find this. Probability of having at least 1 girl is going to be equal to the probability of having no girls and subtracting that from 1. Because it's either you have no girls or you have at least 1 girl. And this is also the same thing as saying there is 1 girl times there, or plus and 2 girls plus 3 girls, but then this is going to take much longer than being intuitive and rearranging it into this. So let's try to find the probability of this. So this is going to be the probability of having no girls. And again, total number of committees is going to be 12C3. And in the 3 slots possible, if we have no girls, that means we have all 3 boys in this. So if we have 3 boys, or sorry, if we have 5 boys and we are choosing 3 of them, it's going to be equal to 5C3. So you get this, and then if you evaluate this, this becomes 21 over 22. So that's exactly the value we're going to be inputting here, and this is going to be 21 over 42, and the probability is going to be equal to 1/2. So yeah, this would be kind of an extension of Bayes' theorem and including the combinations to find probabilities right here.